I'll start shoveling. And you guys are gonna do some gardening?
I am a seismologist, and I use seismological data from all over the world to try and figure out the dynamics of the Earth's interior.
There's not a treasure buried in here, but it's our seismometer, which is our treasure.
But then I became part of this Finite Earth luncheon, where lots of researchers and scientists from across the university came together to talk about anything related to finite Earth. How are we going to make sure that we don't destroy our Earth? And how can we sustain the Earth as a livable environment?
So this is 7, and then
First well.
there's a sensor here.
I'm really interested in the intersection between urban conservation and cities and people.
So this is a groundwater well. It's 1 meter deep into the ground.
Markham is an area that's pretty low-lying and it gets flooded pretty frequently. And sometimes citizens look out and they see water pooled on the prairie and they think, well, that's where my flooding's coming from. But that's an area that's not paved over and can absorb some of the rainwater.
This is a real-time log of temperature, pressure, and depth.
We wanted to see, is the wetland helping to minimize floods? And then in the future, we are expecting more intense, frequent storms. So that can help to make predictions.
This one's measures soil moisture, and this one, the blue one, we only have one here. It measures salinity.
Now that we have all this data, we can also make collaborations with other people that have other sensors, and they can come and use our data to answer their questions as well.
Shortly after arriving at Northwestern, I became very motivated to install a local climate station. There's rainfall and temperature, barometric pressure, there's solar insolation. It's really wonderful to see the data. You can obviously clearly see when the sun comes up and when the sun goes down. It's iconic for the university to have its own climate station. And with enough time, we're not quite there yet, but with enough time, we will be able to establish the climate norm for campus.
Some people are measuring the hydrosphere in the atmosphere, and I'm measuring the solid Earth. So the hydrosphere and the atmosphere cause noise on my signal that I want to remove so I can study the solid Earth.
And guys, this is us. Well, this is us right now, like here. This is from midnight to now.
We have little earthquakes in northern Illinois, from time to time. Those earthquakes are likely part of a much larger pattern that we'd have to wait thousands of years to see.
So this is the sand tube. The sensor's wrapped in a plastic bag and then buried in sand.
Basically, we collect the data from these stations that we have in the Chicago area, and we can combine it with data from other stations all around the US and all around the world to make CAT scans and ultrasounds of the structure of the Earth's interior. It's that geodynamics that determines our planet's future. Are we going to have more earthquakes or fewer earthquakes or more volcanic eruptions or less volcanic eruptions? Right? Are we going to look like Venus or Mars? So what I found interesting in the Finite Earth Group is how people approach data, but also the sustainability factors, like how are we going to make sure that we don't destroy our Earth, right? That we acknowledge its finiteness, and how can we sustain the Earth as a livable environment for ourselves.